This is week 4 already? Or I guess the end of week 3, right? Because we started on a Wednesday. It's a little weird. We'll call week 4. So we're moving into branching, which is our fancy term here. Stuff finally gets more interesting once we can do branching here. Our code can do different things based on different inputs or different values that it has. So instead of it being the exact same every time we run it, maybe we do some different arithmetic based on the numbers, but it's the exact same sequence every single time. Now it'll be a little different, and we can make choices and say, okay, if I was given this, now I got to do something different. This could just be a lot of fun. Let me fire up PyCharm here. So there's a lot of sections here in Zybooks. They're really small, though. They're really small sections, so don't worry too much about it being a lot here. So we'll get through most of it today. We'll have our lab. We'll do some practice, have a lot of fun with that. And then we'll finish it up on Wednesday. Just kind of keep that schedule going. I forgot to update the projects because I forgot to do that on the 11th. So I'll move those down in the syllabus just a tiny bit, and that should be fine because we've got a little bit of extra time here. So I'll move those just down a week, right? Because we from the Wednesday to the Monday for these. So next Monday, project 1 is due right before class starts. If I had $1 for every time someone said they thought it was due at midnight, I'd have a lot of dollars. Right? Not enough to retire, but I have a lot of dollars. So before class starts, right? Because in class next Monday, I'm going to go over the answer. So I'll show you how I would solve that problem. Okay. So plan accordingly. If you don't show up and tell me you're not going to watch the video, I believe you, but I'm still not going to take it late, right? Because that's just not fair to anyone else. So we've got some time today. Get it started on an in-lab. Once you get the lab done, great. Chat with me on Wednesday about it if you're having issues. Don't wait until Monday morning next week to tell me it's not working well. Okay, there's not very much time, and I get here like right at 12:30. So try not to wait until Monday. That's the best I got. I wait till deadlines all the time myself. Like if someone gives me a due date, like, hey, I need a letter of recommendation, I need it in 4 weeks from now, I'm going to forget about it for 4 weeks. Like, you'll get it the day it's due because that's the deadline you gave me. So I get it. I get the temptation, but try and start early at least here. All right. So for branching, so we have really this way of you can do one thing or you can do another thing. That's the most basic branching we can get to here. And people love these flowcharts. I've never loved flowcharts, but some people like pictures. This idea of how do I put the process, the sequence of this thing happens, and then this thing happens, and then this thing happens. How do I draw it in a picture? And there is a standard here. We'll talk about the unified modeling language that's been standardized, which is nice. That way everyone draws pictures the same way. And they make a lot of sense because pictures really are worth 1,000 words here. But we're looking at, hey, how do I do something if something is true? Otherwise, I do something else. So in our case here, this silly example says, hey, if you are old, you get a discount on your hotel room. Sure, maybe the AARP gets you a discount or something here. So the decision point, the if something is true point, where we're going to check if this is the case, I need to do something special, we put in these diamonds. Everything else happens in like rectangles and other shapes here. There's a whole standard to it. It's not that interesting. You'll learn more about it later. But the diamond is our decision point. Let me zoom that in a little bit here. It's a little small. So if it's true that your age is greater than 65, if you're old, looks like you get $20 off the hotel rate. Sure, sweet discount. Why not? Okay. That's all that happens. So we're showing a picture here. So nothing special happens if it's not true. If it's true, something happens. And in Python, we actually write that as an if, which is really nice. It looks pretty easy for us to write. So we make a new folder here. This will be our branching here. Oh no, week 4 branching. If I remember to name them by week, it gets easier to sort. Sometimes I forget. How about we do the opposite, though? Because giving a discount to old people is fun and all, but how about we give you a penalty if you're young? Because that's what happens with insurance, right? You all pay more because you're young for your car insurance. blame the statisticians for that. Who's our math major? Who's going to be an actuary? It's your fault. I mean, it's true, but still your fault that you charge young people more for insurance. Did I not? I didn't have my Python file. That's weird. I didn't check the right box. All right. So we can say, okay, let's get someone's age here. So age will be an int of an input. Right? Enter your age. Now, some people might be tempted to give you a decimal point there, but rarely do people say, oh, I'm 27 and a half. They'll probably just enter 27. So int is probably safe here. We could use a float if you want, but int should be fine here. And then our insurance rate, then, or we should call this the car insurance rate. So car insurance rate, we'll say $100. And if we're talking about some unit of measure, we should probably be specific here. So we'll call this like the monthly rate, right? Because otherwise, is it the annual rate? Is it the, I don't know, whatever we want to call it here. So the monthly rate is $100. Now you say if here, so if something is true, well, so if age is less than 26, then we'll say the car insurance rate plus equals $50. We'll charge you $50 more a month if you're under 26. I don't know what the exact numbers are here. It's just for example here. And then, oops, where did that go here? And then we can print your insurance will cost, and we can do this as a formatted string, so it's pretty here, right? And just substitute in car insurance monthly rate. We can even put our $sign. Look at that, it's real pretty here, per month. And give it a run. So enter your age. So if we enter 30, it's still 100. Right? We started at 100. This line of code doesn't run. So if this is not true, it just skips. Nothing happens here, which is kind of interesting. So Python will just jump over this and ignore it. Say, oh, it's not true. Nothing happens here. And you'll notice there's a colon here, and then this is tabbed in. PyCharm does that for me automatically, but occasionally things get kind of weird. And if it's not tabbed in, it gets upset with us. It says indent expected. Once it sees a colon, it expects something to, I say it hangs off of, it belongs to, it's part of that piece here. Oops, there we go. So I'll tab it in one, right? So if that's true, then this bit will run. If it's not true, nothing happens, right? So that's the most basic example here for us. So let's run it one more time. Again, we want to make sure our code does what it's supposed to do. So just writing it, if you never run it and test it, you probably don't have a good feeling that it's going to do what it's supposed to do, because it's really easy to make typos. So an important piece of writing software is making sure that you write working software. So we're going to test and make sure, okay, I tried the 30 and I got 100. I got what I expected. Right? We're not writing a black box. I know what's supposed to happen here. Right? If I put this in, this thing comes out. If I put this thing in, this thing comes out. I need to understand the problem well enough to be able to test it well. So we'll say 25. And now we could charge the extra $150 a month. So $150 a month for car insurance. I feel like that's even too cheap, isn't it? It's more expensive than that lately. Even though they promised it was going to get cheaper with that legislation. My rates didn't go down much. It made me sad. But that's okay. All right. So it's a quick if here. That's all that's happening here. Now, let's do another one here. So we have two different things that can happen. Maybe we'll have if something's true, something happens, and if it's not true, in Python we call that else. So if and else. So we'll say we'll get how about money is an int of an input of enter how much money you have for lunch. Okay, and we'll get some value for money here. So we can say if money then is greater than 10, we're going to print you can go to Picasso for lunch. If it's not true, now I have an else. So now this is not indented in the if. It's at the same level as the if here. And it gets another colon, and then code gets indented here as part of the else. We'll print you can have ramen noodles. Okay.
Does it indent automatically?
PyCharm will do that for you if you put the colon in. When you just enter down a line, it'll stay indented. That's what it's expecting. Now, it doesn't know when to stop indenting, though. So like now I have to do Shift Tab or Backspace or something to get back to the far left here. But it tries to be helpful and give you those tabs automatically. And you can technically have more than one indentation. starts to get weird as well. As long as it is indented at least once, Python's like, oh, this is great. But you can't mix and match, so we can't have two different levels here. Print, they don't give change. I don't know. Like, now like it's upset because unindent does not match any outer indentation level. So they all have to be the same level of indentation. Now what's nice though, like you can shift tab to bring stuff back a line. You can tab to indent stuff. You can shift tab from anywhere, but you can't tab from anywhere. So anywhere you're on that line, you can do shift tab to bring it back one. And then as many lines of code as we want here. And lots of stuff here, right? Anything you want to put that is indented along with the if until it goes and finds an else, or it sees back to outside of the indentation here, that belongs to the if. It's part of the if. We call that a block of code. So this block of code will run if this is true. If it's not true, then the else runs. Right? We say if this, so like our diamond would say, okay, if this is true, go this way. If it's not true, go this way. Right? So two different things happen. So if you got enough money for Picasso, you can go to Picasso. If not, you're stuck with ramen noodles. And not even the good ramen either. We're talking like the cheap ramen. Like cup of noodles if you're lucky. Which now you can microwave. Super cool. I didn't know you could, it's not styrofoam apparently. So you can microwave them now. That's really handy. You don't have to like make boiling water and then pour it in. No? Okay. I'll just reminisce about being an old person then. So that's our basic if and else. So we can put these things together. Now, these make a lot of sense, right? You're familiar with greater than, you're familiar with less than, you're familiar with like greater than or equal to. Right? Those are pretty standard math symbols here. So we call these relational operators. How does something relate to another, right? And we've got a couple of them. We could say, how about like our guess will be equal to an input, guess a number. And I can say if my guess is equal to 42. So we can't use a single equal sign, because remember the single equal sign is the assignment operator. If you want to say is something equal to another value, you use the double equal sign. You're saying does it equal? I don't know, it's two equal signs rather than one, because one is assignment. So you can technically say guess equals 42, but it's going to get mad at us. Like that doesn't work here. You can't put that with an if here. The guess double equals, does the guess equal 42? Then we can print, you guessed it. And if they didn't, I will print wrong. Right? So if something is equal, we can do this. Now we also have the opposite. We could say if it does not equal something here. So really it's just a style preference here. Do you want it to be the true case up here, or do you want it to be the not equal case up here? Right? Either way, so we could say if guess does not equal, that's exclamation mark is the not operator here. So not equal 42, we'll print wrong, else we'll print you guessed it. Right? These two are basically identical here, but in one I chose to check if it was equal first, and the other I chose to check if it was not equal first. They do the exact same thing, right? There's more than one way to make code work. This is just a style preference to this point, so whichever one we want to do. Now, technically, when later on we'll get into this in further classes and things, if you want things to be fast here, for our purposes, we could care less, but just keep in your back pocket. You want the case that is most common to be checked first. So if it's most common that they're wrong, you want to do that thing first. Because as soon as that matches, we know what we're doing, we can skip the rest here. If we have to check it every single time, and it's not right, and it's not right, and it's not right, and it's not right, and then go to these other cases, it's just ever so slightly slower. For our purposes, we're not going to do anything that many times where it'll matter, but when you do something a million times, those little tiny bits of speed up, eventually they matter here, right? So when you scale things, sure, we care about speed. For our purposes, we get to be lazy. So we can say if it does not equal. So this is does not equal, and this one is equals. Right? Greater than, equal to, less than, those are all pretty common here for us. So those are our relational operators. And now you can even do fun things with strings in Python, right? We can compare, does this string equal another string? Now, if you think back to what we know about strings, right, they're really just stored as numbers. Those Unicode values we looked at because I think they're entertaining. When it checks to see does a string equal another string, it converts all the characters to number, leaves them all as numbers. It doesn't even need to treat them as characters and say, do the numbers match? So we can check, we'll say like name is an input of your name. And if name is equal to Eric, we can print howdy, else we'll print who are you? I don't know. So if the name equals Eric, so it's going to convert, does the first character equal the value of a capital E? Does the second character equal the value of an E? Does the third character equal the value of an I? Does the fourth character equal the value of a C? And because these are stored as numbers, and the capital E is different than the lowercase e, it's going to be case sensitive, right? So checking strings is case sensitive. Okay, so we get a bunch of different things happening here. So we have an age, we have money for lunch, we got $12 for lunch, we can go to Picasso, and we have to guess a number. We guessed 42, definitely got it right. So if I do lowercase e Eric, it doesn't match, right, because it's not the same. So this gets to be a little tricky when we're asking for input here. So we've got a couple choices. And it's really just a style preference here. I like things to be lowercase. I don't know why, but I feel like when I read uppercase things, it's like people are yelling at me, and that makes me feel bad. So I like stuff in lowercase. So if I want to check their name, no matter if they entered uppercase or lowercase, I'm going to do my value in lowercase here, and after name, I can say dot lower. So if I take name and change it to lowercase here, I can compare it with lowercase Eric. And then if whoever's running the program here typed in capital E Eric, or they put on caps lock because they were angry and wanted to yell at somebody online, they typed Eric in all caps, it'll match. If they typed it all lowercase, it'll match. Right? It'll match all the different cases here. So it makes life easier to compare the lowercase version of name here. And now, remember, when we think about strings, strings are immutable. So when I say name.lower and I get a lowercase version of name, it doesn't change the value of name. So later on, if I want to say, print their name and tell them so-and-so, how to, yada, 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 it hasn't changed what they typed in. So if they typed in the name in all caps, we're going to spit it back out of all caps. We'll match their energy. Sure. So this doesn't change what we're storing. This just changes it while we go and compare it. So we can use lower, or you can use dot upper, right? You can say, hey, I want to uppercase here. Again, I just prefer lower. It's just a style preference here. Use lower to don't worry about casing. So this way, no matter how they typed it in, we'll figure it out here. And we could, do a little formatted string and say howdy name. Sure. Otherwise, we'll do another formatted string, we'll say name, who are you? I should have put that at the top. Let me go put this one at the top. That way it runs. Oh, I know. If you right click, there's a run execute selection in Python console. It's probably not very handy for you, but this way I can run just a little bit here. Yeah, I want to let, oh, come on. No, one more. That's right. I didn't get the whole selection. There we go. Enter your name, Eric, and we get howdy Eric. Yay. So it runs here. This is just the console version rather than the full run. It just saves me a little bit of time if I'm doing little demos. All right. So checking for strings, this might be handy for your project that's coming up, maybe if the user typed something, that's an option. If you're not fond of this, when you ask the user to enter values, ask them to enter numbers. Right? It's totally up to you. So you can tell the user, hey, press 1 for this, 2 for this, 3 for this, pretend like it's a phone menu, right? 1 for customer service, 2 for whatever. So we could do that. So we could print or get an input of. Now, the inputs get a little bit ugly if we want these really big menus of like 1, 2, 3. You can do them with new lines if you want, or you could just do prints. Right? It's, again, just a style preference here. So we'll say, enter 1 for, we should be like a coffee shop, right? So welcome to Eric's coffee shop. Enter your order. And we'll say 1 for coffee, print to espresso. That's too many S's. There we go. So 2 in the second side. There we go. 3 for Americano. Print 4 for... Wow. I don't order other things. I'm really boring. What, people get lattes? That's a thing, right? I don't really like milk in my coffee, so it's not a common drink for mine. That's fine. And 5 for... I can't even spell cappuccino, so I'm not going to try. We can have tea, I suppose. We'll have the sad drink here. Tea's great. It's great. It's just not as caffeinated as coffee, so it hits a little different. But sure, we get 1, 2, 3, 4, 5, and then maybe their choice here, or their order, will then equal an int of an input. And now, I don't even have to ask anything here, right? You can leave input blank, because I've just printed it all out here. The reason I like 5 different prints here is that it feels like it's easier to type this out than to put it in a single string with my own new line characters. But we could do that, right? It's just going to look really ugly, right? This could be welcome to Eric's coffee shop, and then a \n, 1 for coffee, and a \n. Like, this just looks ugly, right? So we can see why that's not fun. I'll just leave that one commented out. But you can. Right? So in your program, if you want to ask, hey, what are you serving for your party? You can say enter a 1, 2, or 3, or you can just let them type it in. Right? Either way works. That's okay. Now, at this point, though, we've only looked at it's this or it's not this. Right? So how are we going to check to see if it's one of 5 different things, or really if it's not one of the 5? Right? It's 1, 2, 3, 4, 5, or anything else. Right? Someone put a silly video out. I don't know why people like doing reels of being obnoxious to customer service workers or food service workers, but they keep doing it. I feel so bad for people. But he pulls up to a Culver's and he's like, "Oh, can I get a pasty?" This is a Michigan store. They're like, "We don't serve that, sir." He's like, "Oh, can I just get a Verner's?" "We don't have that, sir." "Can I get Better Made chips?" "We don't have that." It's like, why are you here in Michigan? Like, we shouldn't abuse our customer service people. Like, the poor food service people are just trying to get through the day. Just be nice to them. But how do we check, right, in Python code? So at this point now, we're going to kind of have a bunch of if statements. So really, in English, we'd say if it's this, or if it's this, or if it's this, or if it's this, or if it's this. Or we might say if it's this, else if it's not that, if it's this, else if it's this, else if it's this, else if it's this. Right? So it's else if, right? Because if it's not this, we're in the else. Okay, else if it's this. No, not that. And you just chain these things together. So we can make a big bunch of them here. So we can say if then my order is equal to 1, we're going to print, dollar for coffee. Sure. Now we could say else order equals 2. Or, I'm sorry, just if order is 2, print 2 for espresso. And then if order is 3, we'll print, what is that, $1.50 for an Americano. I don't know why. Americano. If the order is 4. Right, we could do this. It's not very pretty here. So lattes are expensive, right? Well, it's like, what, $3 for a latte? Latte. And if order is 5, we'll print, tea is pretty cheap, right? We'll do $1.50 for tea. Sure. So if it's this, if it's this, if it's this, if it's this. The problem with this is that Python has to check each and every one of these. Again, it doesn't really matter for us, but it's going to be a little slower because if it's a 1, we know it's not a 2, a 3, or 4, or 5 already. And then at some point here, if we wanted to say if it's not any of those, really like we wanted an else, print we don't serve that, or I didn't understand, or please try again, or whatever message you want to give them here. Now, this else is only going to be attached to the if above it. So we only get if else for the very last, is it a 5 or is it not a 5? So if I entered 1 for coffee, it's going to say, okay, it's a coffee. Is it a 2? No. Is it a 3? No. Is it a 4? No. Is it a 5? No. Else. So it's not attached to the rest of them. So it's really hard for us to give that wasn't a good option here if it's just a bunch of ifs. So if we didn't have to do this, sure, that's fine, but it's not very friendly. So to make them all attached here, to chain them together, we have to add in that else if. And now the fine folks at Python decided typing else If was too many words, too much typing, because we're lazy people, right? So we say elif, else if, elif. We saved 3 keystrokes. Sure. So elif, 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 elif. So now we have a chain of if, else if, else if, else if, else if, else if. And when we put them all together like this, they're going to be mutually exclusive, right? One and only one of these will run. And as soon as one of them runs, Python says, great, I can skip to the end. Because if it's a 1, it's not any of the others. If it's a 4, it's not a 5, it's not an else, right? So at some point, it will just skip. Or if it's not a 1, 2, 3, or 4, or 5, now we finally get, we don't serve that attached a single time, and it'll actually make sense here because it'll work, right? Rather than, oh, you wanted a coffee, and we don't serve that. Which didn't make any sense for us. I didn't even bother running it because it just looks silly. So this chain of if, else if, else if, else ifs gets to be, make these mutually exclusive. So we can get a little menu, right? Again, 1, 2, 3, 4, 5. If you want, you could say, does order equal coffee? Like that? Sure, we could do that. But again, probably want to lowercase that. But it's an int, so it's not even letting me lower it, right? So probably not comparing to coffee, right? Just the 1 is easy because that's our integer value. So if you like number menus, great. If you want strings, that's okay. You can just have to lowercase it. Now, having to do order.lower, 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 order.lower seems a little tedious, right? So you could make a new variable for it if you wanted. Or you could just write on their input here, you could lowercase it because we're not going to spit the order back out to them. Right? Or maybe you do, depending. It just depends on what you're going to do with it later. Right? If you wanted to build out a whole receipt of things, hey, here, thanks for your order. Now, in our case, you're only allowed to order one thing, right? No complicated orders here, no group orders, just one thing and get out. And I'm sure the folks at Starbucks would love that. They just limited people to get your order and get out. But that's okay. All right, how are we doing? Let's see. Let me zoom back out a little bit here. Equal values, ranges with branches. Ranges are fun here. So if we wanted to see if there's a range of values, right? If it's less than something, right? We did that, right? Is your age less than something here? But now, so this example here says, oh, okay, we're going to change insurance even more. I guess you get a discount if you're really old. I feel like they charge older people more. Maybe that's after they're like 70 or something and are bad drivers again. But if you're over 40, apparently you're a good driver. I don't know. I don't actually run the stats on this. So if it's less than 16, else if it's less than 25. So we essentially have a range here. So it's not less than 16. Now we're looking at if it's between 16 and 25, right? Because you can't get to this point if you're less than 16. So the range here is implicit. We're not explicitly writing that you're between this and this. It's here for us, right? Because you can't get to this place if this was true. So because we're doing them in order, it'll work for us with these implicit ranges. Now this works and it works pretty well. Sometimes it's easier to be explicit with it, but that's okay. This will be fine. This is definitely an option for us here. So this is the implicit range version here. Let's go do the explicit range for fun. I'll just copy their code here because I'm shameless. I try not to use all their examples, but sometimes it's easy. So if we wanted to get explicit ranges, so instead of saying, just relying on the fact that, yes, I know it's less than 16, what Python lets you do is say 16 less than user age, less than 25. So this is an explicit range here. A lot of languages don't let you do this, but Python does because they're cool, right? So we're just sandwiching our value in between a less than and a less than, right? So it's true if, and you just kind of do it one side at a time, right? I don't think we do these often in math class, I feel like. These sort of ranges are a little weird, but, right? 16 is less than the user's age, and user's age is less than 25, right? And we just kind of read it. It's between them, right? So that's the explicit range here. So we can use those. So we do the same thing here. So we'd say 25 less than the user's age, or user's age, I guess, is greater than 25. So this should probably be equals to then, right? Because if you're less than 16, you can be 16 and hit 25. I guess we got to be a little bit careful, make sure we're using the right ranges here. Otherwise, you get our 40 and up price. Sure. So we can steal this from Zybooks. I should put a note in here that I copied it, because I will model good citing my source here. Okay, how's that? From here. Or modified from. There we go. Because it's kind of a parts of it are paraphrases. This is probably close. You know what I meant, right? I'll know what you meant if you gave me a URL here. Okay. The modified versus copied is nice to know, though, right? If you've like paraphrased it, cool. If you just took a direct quote, it's a little bit different, but that's a little hard to show, and that's okay. Right? We're not going to put quote signs in, but cool. So that's our insurance. So that's our ranges of values here. Then we can check. There we go. Fun. Dealing with gaps, that's fine. Multiple features with branches. So if you want, you can go crazy here, and you can put an if inside of another if. Right? So this is like, okay, if the user entered a 1 and their number of items is less than 0, or no, I'm sorry, if they entered a 2 and their number of items is less than 0, something happens. Sure, we can do that. So this one is, insurance is a little weird here. Let's see, let's come up with, let's do 2 different values. So let's say, what's the temperature outside? Okay, so we'll have temp, and again, because we're asking for a value here, I'm going to give you the unit of measure, because that's a good thing to have here. So temperature, I'm terrible at spelling, in, oh goodness, Celsius. Okay, I liked that. I didn't like Celsius. Celsius misspelled? Rename to delicious? Nope, okay. All right, I think it was a little confused here. That's fine. So that probably, again, an int. Most people don't say, hey, it's 22.5 degrees. Int is probably fine here. An input of enter the temperature in Celsius here. And then we want to know what the weather is, right? Is it sunny? Is it raining? Is it snowing? Is it something here? So then we'll have a weather is just a regular input of enter the weather. And then if the user doesn't really know what that means, like if I just asked you what's the weather, you might just give me the degrees, right? It's 70 out, because that's what the weather was, right? So if it's kind of vague, we'll just tell them like sunny, rainy, snowy, sure, something like that. Like tell them, right? Nothing wrong with giving some hints to your users here. Did I misspell Celsius? Does it want to do delicious again? Rename to, no, not to delicious. Really thought it knew that word, but that's okay. I think I can add it, right? Save Celsius to the dictionary. Is that spelled right? Define Celsius. Celsius. Yeah, that looks fine. Okay. Oh, that's an S. That's why. S. It's sus. English is hard. All right, and then enter the weather. So now we want to do 2 things, right? We can say, hey, if something is true, right? So our first if, how about we say if the temperature Celsius is greater than 20, right? It's a pretty decent day, right? Pretty warm out, right? Then I can check, hey, if the weather is equal to sunny, or maybe if it's not sunny, right? If they didn't tell me it's sunny, then we'll tell them, don't forget your umbrella. Your umbrella. It's probably not snowy if the temperature is more than 20, right? That's probably a pretty fair guess here, right? If it's not sunny, or I'm sorry, if it is sunny then at this point, right? If it's anything other than sunny, we'll tell them this. Otherwise then we'll tell them print, I don't know, it's nice out, wear shorts. Sure. And then for the rest of the temperature check, maybe we'll print, you'll want pants. Right? Regardless of the weather here, if it's less than 20, maybe they want to wear pants. I don't know. This is a bit of a stretch here, I'm sorry. But this is an if inside of an if. And you can have as many of these things as you want here, right? We can do it again. So we can say, hey, if their age is less than 25, print, forget the umbrella, you're invincible. Right? You're young enough, you're invincible. Rain's not going to hurt you. You're fine. Once you start getting old, then the rain hurts. I don't know. Right? And then we can do even more, right? So really, as many of these as you want to put inside of each other, you're welcome to do it. It gets a little silly at some point if you're like 4, 5, 6, 7 levels in. Yeah.
Do you need an else with an if, or can you just have an if?
Yeah, you can do just the if. Yep. You don't have to have the else. So this is only if this is true, I want to do something. I think that was one of the first ones here. Like, hey, if your age is less, then you could charge more money, right? A lot of times we have an else, but not all the time. Yep. All right, so that was looking at nested ifs here. There's lots of fun with those. And comparing data types, common errors. This is pretty good. This is a good section. Looking at issues with values, branching errors. Yeah, those are all good practice. That's stuff you can look at. The membership operator. This one's super cool. This is really handy here. So if I have a list of values here, so maybe we had like that list of dinners. Right? Our dinners was going to be ramen noodles, spaghetti. Why do I always pick the hard ones? Noodles, pizza. I forget what else. What other things we're going to have for dinner? Things that are easy to spell. Tacos. There we go. All right, easy. So then I can ask them, hey, what are you thinking about for dinner? You know, so then the dinner choice is an input of what sounds good for dinner. Now, if I want to know if whatever they entered is part of my list here, I could say, hey, if the dinner choice is equal to dinners, right, at index 0, right? Print, we've got that, right? Else if the dinner choice, and this is going to be really easy, so I'm just going to copy paste, is equal to index of 1, print, we've got that. This does not sound like fun, right? And then what if you add more dinners, right? And then I'm going to have to add more of these things, and I'm going to get really confused. So turns out there's an easy way to do this, right? Who knew? So we would say if your option is in the collection, so I don't use indexes anymore. I just say if it's in some collection. So we can do this with strings. You can check if a character is in a string, or even a string of characters, like a substring is in that. You can say if it's in a list, if it's in a tuple. Now for dictionaries, it gets weird. Sets is pretty easy, but for dictionaries, pretend it's like a set where you only have the keys, right? You can ask for if something is in a set. Hey, do you have this cool collector stamp here? Actually, they just released D&D stamps, and they got me very excited for stamps again. It's the first time since I was like 5 years old that I thought stamps were cool. But sure. So if it's in a collection, if it's in a set, that's easy. But if it's in a dictionary, now we're only going to look at the keys, right? So we had that like the list of students here, or was that our grade book, right? So grades was a dictionary with our curly braces. So Eric :A, and then Jeb :B, right? So if I want to check if something is in the dictionary, I have to check if it's in the keys here, right? So I can say if Eric is in grades, then I know the key is present. So with dictionaries in, we checks keys, not values, right? Print, Eric is in the class. This is really weird because unlike elementary school and middle school where like there were at least 3 Erics in every class I was in, I don't run into a lot of Erics anymore. I think the name's kind of gone out of style. That's okay. Okay. So we can check if it's in a list of values pretty easily with the membership operator. Is it a member of this collection? Is it present there? Print. You'll have to run to Meyer to get that. Does it not know how Meyer? That's capital M? Just doesn't know Meyer. I think I spelled that right. I'm so bad at spelling, I'm sorry. That's why I don't teach English. That and getting a master's degree in English sounds awful. Can you imagine? Like, yeah, I want to take more composition classes. Like, no thanks. No, my sister-in-law has a master's in English. I don't know how she did it. Like, she's a smart lady, but just so boring. English is great. I'm sorry. English classes are very useful, which is true. Like, you could be a super fantastic developer and know all sorts of things about code, but if you can't talk to people or like communicate well, and written communication is kind of important as well. If you can't draft an email to people, no one's going to care that you're smart because you're just going to sound dumb, right? You got to be able to talk and communicate well. So composition's important for that. ChatGPT won't save you all the time, I promise. Like, it's just awkward when people I can tell now when people use ChatGPT to send me emails. It just sounds weird. Like, I don't know.
I remember that like the first class you told us about like this guy who like posted their article.
Yeah.
I searched it up. It was like I saw the actual thing.
Oh, you found the article
Yeah,
that
it was like,
from ChatGPT?
Yeah, I was like, of course I can assist you with that.
So,
How did that editing?
How did I lists?
yeah. In
editing team not get that though?
in C++, we teach that for our regular computer science students. It's very particular about using a couple tricks and shortcuts that we don't teach students because like we're trying to get you to learn how to do it. So when you see that in someone's code, like right away, I'm like, oh, they use ChatGPT. Like, I can just tell really. Now Python's a little bit trickier. Depends on what we're doing in Python. This last bit here, we'll get to the conditional operator, conditional expressions. ChatGPT loves these. Usually these drive me crazy because I'm just not a fan, and it just is crazy here. So expression when true, if condition, else expression when false. It just sounds like a bunch of nonsense here. But we could say, hey, if we're going to have the cost, or not what do we want here? Yeah, that's fine. So cost. So we'll ask them what are they going to have, right? So how about for dinner? So if the dinner choice, so if my dinner choice is equal to ramen, and we'll do lower on that, right? Lower on ramen. We'll say then the cost is $1. Not even $1, right? Was it 33 cents, 0.33? You can get 3 for $1 now. Unless you buy them in like the big cases here, you can get it even cheaper. But we go through a lot of ramen with 7 kids. Like they love ramen noodles. I do too, but that's fine. Otherwise, the cost is probably, I don't know, more. We'll say $1 for some of these other options for noodles or pizza or tacos. Maybe $2 here, sure. So if the only thing we're doing is setting a value based on if this is true or not true, this is 4 lines of code, and that's a lot of typing, and good developers are lazy. So you might opt for that conditional expression. You might. It's a little awkward to read, but you get the expression when true, if the condition, else the expression when false. So we're going to say cost equals 0.33 if dinner.choice, dinner choice lower is equal to ramen, else 2. I don't think this saves a whole lot of time here because it's just awkward, but ChatGPT loves it. And if you've been doing Python for a while, it gets to be secondhand nature. And you're like, oh yeah, sure, I get this, but like else 2, so cost will equal to if this is not, like, it just feels really backwards still to me, and I hate it. But when I see these, that's a pretty easy giveaway that you didn't write the code, right? Maybe you're smarter than I am. Honestly, it's possible, right? I'm not going to tell anybody I'm a genius, like just your average guy. So yeah, if you like these, great, use them. They just drive me crazy. So it's the exact same thing as this. This is our conditional here. So handy, I guess, if we're just assigning, hey, this value or this value. It just reads really weird though. And really, the philosophy of code is for people, that we should be able to read the code and understand what it's doing, and the next person after you, when they take over your responsibilities, when you move on to bigger and better things, anything that slows down your reading of code, I dislike. Right? It should be relatively easy to look through the code and know what's happening. And if I have to stop and think about this because I don't remember how these things work, it irritates me. Like, this made me slow down because I had to actually stop and think about what was happening here. Right? That's all. So just following after that, it irritates me. So you can use these ternary expressions or conditional expressions. y equals 5 if x equals 2, else 9 times x. Sure, I guess. Okay, they're not the end of the world. They're awkward here. Our order of evaluation, I complain about this all the time, right? We know how these work, but now we get to add in logical operators. Logical operators are lots of fun. So parentheses, arithmetic operators that have their own set, right, that we follow, and then relational. So if we do arithmetic, which I think makes sense, we can say, hey, if 10 times 2 is less than 30, right? We're not going to do 2 is less than 30 times 10. Right? You just can't really do that, right? So it hopefully makes sense logically that you do your arithmetic first, and then you'd compare the relational operators, right? So I think that part's easy enough to follow here. But now we get to start adding in logical operators. So logical operators, they let us combine logic. So we can take two things and say, hey, if this is true and this is true, right? Or I could say, if this is true or this is true. If either one of these cases is true, I could do something here. Now, it takes a little while to get used to these here, but my favorite way of remembering them is I remember McDonald's fries, because they are garbage and nasty, awful things that no one should ever eat. So when I go to McDonald's and they say, do you want fries with that? I say no, all the time, ever. So if I say, I want a burger, and they say, do you want fries with that? I say no, because I don't want it, right? Do you want a burger and fries? The answer is no, because I don't want the fries. If any part of the and is false, the whole thing's false, right? So I can say, hey, if true and false, then the whole thing is false. If I'd say false and true, the whole thing is still false. False and false, the whole thing is false. Only when it's true and true is the whole thing true. True, right, with our logical operators. So if you like whatever they're offering, hey, do you want a milkshake with that? Because our ice cream machine happens to be working because it's a blue moon. Yes, sure, I'll take a burger and a milkshake. Yes, I want both of those things. Right? But if you don't want one of the things in the list here, then the whole thing is false. So only if it's true and true do we get true out when we're anding together. The other option we have is ors, right? We can or. So if this or this is true, right? Now, if you like to annoy customer service workers, which you're a bad person if you do, but sometimes it's amusing, I suppose, if they say, do you want this or this, and you say yes. That's the correct answer, right? But what they were expecting you to do is say, yes, I wanted this choice or this choice. But yes is correct, right? Do you want a burger or a milkshake? Yes. I want one of those, right? So with ors, we can say true or false. The whole thing is true. I could say false or true, and the whole thing is true. I could say true or true, and the whole thing is true. Or if the only time it's false is if they're both false, right? If you don't want this, if you don't want the burger and you don't want a milkshake, do you want a burger or a milkshake? No. The whole thing's a no. The whole thing's going to be false here. So we have ands, and we have ors, right? It takes a little while, and these can be a little weird to use here. But what these let us do is not have to do nesting sometimes, right? If I want to start combining these things here. So I can say, hey, if the weather is not equal to sunny and the temperature in Celsius is less than, so if it's greater than 20, right, on a single line here now, I can say if this is true and this is true, then we'll say don't forget your umbrella. Then else if, okay, well, now I need to know if it's nice out, we should wear shorts. Then that was if the weather is greater than 20, right? But it's not sunny. Okay, so really then all I have to check then if the temperature is greater than 20. Oops, this one here. Because if it's not sunny and it's greater than 20, this will run. So if it is sunny and it's greater than 20, we're going to print wear shorts. If it's not one of those, then we can say wear pants. Wear pants. So it just lets us combine things here, and it doesn't always work well. Sometimes you don't want to have a bunch of different checks in here, and a nest is easier. But in our case, right, we had 3 different things happening. Essentially, we had umbrella, shorts, or pants. So now we have if, else. So we can use the logical operators here to combine them and say, okay, this one and this one here. Right? So it only runs if they're both true. So if it's is sunny, then this part isn't going to run. It doesn't matter what the temperature is, because as soon as it sees a false, it knows when we're anding, the whole thing's going to be false. It won't run here. Then we'll get to the next check. Okay, is the temperature greater than 20? Great. If it's not, then or else. Here we get a pants. We can wear pants. So we can combine all sorts of fun statements here if we wanted, right? Maybe we'll check. We'll have them enter some numbers here. So we'll have number 1 equals an int of an input. Enter your first lotto number. Right. I'm just going to do this. We'll do 3 times, because otherwise it just gets to be kind of silly here. We'll do 3. Number 1, 2, and 3, and then we can say, hey, if number 1 is equal to what should the winning ticket be? How about 7? And number 2 is equal to 2, and the number 3 guess is equal to a 5, and you win the lotto. Right. Otherwise, you lost your money. Right. So this is true, and this is true, and this is true. And you can have as many of these as you want here. You can and till you're blue in the face, right? Then we get a win, right? We can also then add in ors, and then it's going to be where it's a little bit complicated here. So ands actually happen first, and then ors happen, right? So sort of makes sense, but not all the time. It gets to be a little confusing here. So then we'll say, I don't know, how about, so we'll say cheating equals an input of, do you want to cheat? And I'm just going to tell them, like, enter a y or an n. Just give them a little prompt here, just so they know what I'm expecting. So if 1, 2, and number 1 is 7, number 2 is 2, and number 3 is 5, or cheating is equal to a y. Now, because all the ands happen first, I'm going to get all of this together first before I or. I feel like that's a little risky sometimes, so like it doesn't hurt to put some parentheses in. Sure, it's redundant, but visually now I know what's supposed to happen without having to remember what the order of operations is. So I like putting parentheses in. So we're going to say, okay, if you pick the right numbers, or you want to cheat. It's our code, right? We can cheat if we want. We'll enter our cheat codes. Sure, we just won the lottery. Right? So we can say, if this is true, and this is true, and this is true, all of that will boil down to a single true or false, right? Or, if I'm cheating, is yes. So either I got them all right, and I have a true on the left, or cheating was true on the right, and the whole thing will be true, because I'm oring those together, right? So you can mix and match as you go. It gets to be a little weird as you start putting lots of numbers together, but it's definitely doable here to put them together. Yeah. You can also use the not keyword. Not's pretty handy. So we checked for like membership. We said, hey, if your dinner choice is in dinners, or you could say if it's not in dinners, right? It's just a style preference, like putting the else in here first, essentially. But not is the opposite. So not true is false, and not false is true. Right? So that technically is another logical operator here. We have not. So not true is false, and not false is true. Right? There's that funny story about the guards, that two guards at 2 different doors, and one door you get out of and you escape and you live, and the other door you fall in a trap and die. And one guard will always tell the truth, and one guard will always lie, and you only get asked one question. Remember that? You say, what would the other guy say? Because the guy who always tells the truth would tell you that the other guy is going to lie and tell you to go through the door, and you go through the opposite. And the guy who lies will always lie. So if you say, what would the other guy say? He's going to lie about what door is the true door, so you know to do the opposite. It's not. It's just the opposite here. That's all. That story probably didn't help at all. Okay. I tried. So you can also throw nots in here as well. not this or this, I don't recommend that. Those just get to be a little awkward in your reading here. But you can throw nots in, like not bats less than birds or birds less than insects. What? Okay, well, what's the order of operation here? Well, it's not going to be not bats, right? So not attaches to the first one before the or. Right, so we looked at the order of operations. Not happens before ands and ors. So we invert trues and falses here. All right, so that's order of operations. Let's see. Code blocks and indentation. Yeah, they get indented. Conditional expressions. Awesome. Did we get through the whole chapter? I went a little fast. I'm sorry. I've had a lot of coffee today. I had to be at the cardiologist this morning really early, and that was sad. Probably shouldn't have had a lot of coffee before that visit, though. But I'm becoming more and more cyborg. I have a little heart sensor right here now. This little like plug-in thing. How cool is that? Like, so I've got 3 different things on my body, like that I'm part cyborg. I don't know, I'm looking forward to the future. We'll see. The Neuralink stuff is crazy stuff. But we'll see. As long as it's safe. I don't want to be the first person. Definitely don't want to be the first person trying it, but I think it'll be pretty cool. Yeah, so the last little bit, this code blocks and indentation, right? We call them a block of code because it runs if it's true, right? Everything that's part of that block will run here. So you want to not change your indentations. Python gets confused really easily here. So this is like, go and fix this so it runs. Python is really cranky about indentation. Like even a single space will upset things, right? So you got to make sure that everything belongs to the right level in which it should be, right? Now, it sort of gives you like a visual view as well. Like if we're just looking at what's happening, you can kind of see, oh, this bunch of code belongs. And I don't know if you can see here, there's like a tiny little gray line here. It might be too hard to see right now, but you might be able to see it on your computer. That says that stuff belongs to the if. And it helps you visually go, okay, where does that line end then to see where the else is here. Just gives you some visual clues here. Because Python gets upset if like everything is like that. And then you get all sorts of red lines and it gets really cranky. So I'm just gonna undo. But you can grab multiple lines to tab or shift tab at once if you want. That's a fun little shortcut, right? So if you wanted to put something inside of an if block, like, oh, hey, I want to do this if they want to do this, right? Grab a bunch of lines and then tab them in. We can do those sort of manipulations pretty easy. Yeah, other than that, it should be fun. Wow, we finished a little bit. I guess we have a little bit of time to start on the project. We'll meet over for lab at 2, and then we'll get some practice for this. I don't want to get too far ahead on Wednesday. Maybe we'll just do a little bit more practice. I can do some more examples. But Wednesday will probably be a little bit shorter then for Wednesday. Does that sound good? Okay, I don't think we need to get ahead into loops or anything yet. So we'll do some more branching practice. And maybe we'll do some more work on the project on Wednesday so I can answer questions in class. Does that sound good? All right, thanks y'all. I'll see you in about half an hour.